Alright, hey everybody. I hope everyone's having a great day so far. Mine's been pretty good, although our allergies are pretty bad today. I think just because it's gotten way colder here, which I'm definitely not going to complain about that, but I do apologize if I need to take frequent water breaks. But I think I'm ready to start programming. So we're still going to work on more shadow meshes, and mostly because I've been having trouble with the way it handles this edge case when the point A equals the point that it hits the boundary and B equals the point that B hits the boundary, which I think the best way to explain that is just to illustrate our problem. So again, I'll get rid of all these extra lights because they're not even functioning right now, and I just want, it looks fine here. It's easier to see what's going on this one since the white texture is not behind it. Yeah, I guess I'll move that out of the way. So this texture is actually like the mask for that the shader is forming for the light. And so we can see obviously the light is not showing up behind the sprite there. But the issue is when we center the sprite exactly on the collider so that the edge of the light's boundary is exactly on the edge of the collider. This weird thing happens where it's like the game doesn't go back up to this point, like it only draws one triangle. So I'm gonna try and see if I can figure out what's happening. It seems like exactly what I said. It seems to go from point A, or rather actually this is point A, isn't it? Because the points go clockwise from the center of the light. So it skips point A. It seems like. And if we pause the game down here, we can see it's trying to draw. Well, I printed out the 4 points here. So A is this one, and the position is -2, 8, and then B. Okay, well maybe this is B. Now I'm confusing myself. Let's actually make a better debug here. So yeah, A, B, hit A and hit B. So yeah, so A is -2. So is that correct? Maybe that's our issue, is that for some reason A is here, but I think that the game expects to be clockwise from the light. One thing I might do is to disable this, because right now the game looks at a collider and adds each edge to the algorithm, but right now I might only add this top edge just so we can try to isolate it. Okay, so right is A. So yeah, I was correct. That means maybe the issue is that the points are getting reversed. So again, like it's gonna be kind of weird because the top edge is the only one that is creating shadows right now. So again, if we set X to 0, so it's exactly in the center, you get this problem again. Okay, let's pause. So yeah, it's creating a 6-point shadow mesh because it thinks that there's a point for A, and then the hit A, and then the corner, and then the next corner, and then hit B, and then B. So yeah, it looks like it is getting reversed because this is -2, which I'm just going to do a sanity check here. So yeah, -2 is this point, and that's not right. Interesting. So I think I need to take a closer look at the code that returns those points. So yeah, it gets A and B from this is segment inbound. So let's look and see what's going on in here. So first it offsets the segment point from the light offset just to get the relative point of the segment from the light, and that's fine. And then it checks to see if it's in bounds, and they both should be out of bounds, so then it goes to this part. So I would guess that the code that's causing a problem has to do with here. I bet what's happening is that since A is exactly on the border, when we try to find a collision, it's just goes to, it doesn't count the exact border point and goes to the other side, and that's why they're flipping. So let's see what would happen. So yeah, approximately direction.x is 0. So let's see. Okay, so it's horizontal, so the direction y is close to 0. Okay, so x for point A, since it's on the right, or okay, so point A is on the right, so the direction is negative 1x, so it's negative here, so that would oh yeah, because then it just flips over to the opposite side. Yeah, so this code is actually wrong because we'd want to flip to the nearest side to the actual point. Yeah, because if the point starts outside of the radius, then we would want to find, yeah, the collision. Okay. Yeah, so this code works a little differently because it just raycasts towards the bound side that's pointing in the same direction. So it doesn't actually, like, if you pass through another boundary first, it doesn't actually check that. I think that this code works the same here. So maybe I should find the closest x and y bound before I do this. I think we could do that just by looking at if this, oh, we actually don't know. I was going to say if we pass a point in here instead of just a vector 2, we would also have the side variable, which would tell us if it's outside on the left of the boundaries or right, for example. And then we could do if else statement to find the actual radius we care about. So let's see, where is this called? So yeah, it's okay. So this part, yeah, finds the raycast with the shadow, or like in respect to the light, whereas these calls try to cut off the line at the boundary. So yeah, these sides are slightly different because okay, so I'm wondering, I'm surprised that I haven't got any trouble here yet, actually. Well, I guess it works because point A is in bounds. Yeah, so the problem is if you try to start this with a point that's outside of bounds. Okay, so I'm hesitating a bit here because I don't want to add a whole bunch of math here to slow down the algorithm, but right now I think we just need to get everything working, and I can try and optimize later if we need to. So yeah, let's actually pass in a point instead of just the position. Okay, so this part is still kind of the same, it's just we need to figure out if we want, basically if we want to find the left or right or top or bottom bounds. Okay, so let's see. Can we just... I was gonna say we could kind of just multiply this radius by the either the horizontal or the vertical side, but we also need to figure out this direction as well. Okay, so let's see. Oh, what was I doing there? So I guess let's do first horizontal boundary and first vertical bound. Then if point horizontal side does not equal 0, then the first is just the bound radius dot x times the point horizontal side. So yeah, if it's negative, that means it's outside the left bound, so that means the first collision would be, yeah, so that's fine. I mean, yeah, the first collision would be on the left side, which is negative. So technically this isn't true if the direction is pointing away, but I don't think I need to worry about that because that should never happen. Like, the direction doesn't actually matter if the point is outside of bounds. Otherwise, the first horizontal bound is bound radius dot x times mathf sine of direction dot x. And this can return 0 if direction is 0, but we take care of that, so it doesn't really make any difference. And so we need to do the same thing with the vertical side. Switch this to y and y, and switch that. And now just every time I use this bound radius y, I need to change it to first vertical bound. Okay, and this simplifies this even a little bit because I don't even have to have two separate, like an if statement here. So here, the direction, we still need it, obviously, to get the slope. But I guess we don't even have to worry about the direction x either. We can just use the first horizontal bound there, and then also here in the line function. Then here we see if the horizontal point is inside vertically, that means that it collided somewhere inside the top or bottom of the bounds. But if not, then that means that, well, considering that the point should be inside, we need to check again to see if it hits the vertical boundary. This is still okay. Hopefully this won't make everything explode. So now instead of sending the position, we just send the point itself. Okay, and yeah, so we see if neither point's in bounds, we need to check to make sure that one of these points collides with the boundary. Okay, yeah, this is still fine. So I think this code will still work. I guess one way to find out. And right now, of course, it still is just using the only the top portion of, or the top segment of the collider. And everything looks good so far. Okay, so good that none of this code broke. So let's see if I change X to 0 and it works. Okay, so yeah, now it does weird stuff on the other side, but that's okay. Because basically if the light is on this side of the collider, we need to change it so these triangles aren't even drawn, so I don't care. Okay, that's good to see. So yeah, last time I was thinking that the problem was somewhere in this add vertices, but turned out not. Alright, so now the next thing I need to do, I guess, is get it so, well actually before we go any further, let's check to make sure that the other segments all still work. Okay, so far so good. Just trying to move it around close to collider and then far away to get all different possibilities. Okay, so yeah, everything's still fine. Okay, so one other thing we need to do here is that, well, I can get rid of this. And this is saying that if A equals hit A and B equals hit B, which happens if they're both on the edge, we'll just always render. But we should probably have a better way to handle this. So I guess one way we can see if a triangle is clockwise is we can use the 2 points A and B and then actually the light position, because the light should be on, or wait. It's the opposite. We need to make sure that the triangle between A and B and the light is counterclockwise. I think. Could have my thinking a little backwards there, but I guess always try it out. And the light is always at the 0 position because we normalize everything so that the light is always in the center. Okay, so let's see if that logic works. Okay, so far so good, but I need to put this in the middle. Okay, so I guess I got it backwards. Yeah, because it draws it here. I guess the way I was thinking, because like here is A and B in the light, so yeah, if it's clockwise, that's how we want it to be, but the shadow actually goes the other way around. Or, no, it still starts at A, but it's on the other side of the collider, but this turns out to be fine. Oh, and it's already at 0 and it's working. And you can see when you go to the other side, it doesn't even create the triangle, so you don't have that weird half shadow like we did before. Okay. So I think we're almost done with this. So we did that, we did that. So we have corners. Let's see. How can I test this easily? Let's set this platform at a central location. -3. Just so I can set an exact position for the light. So what I want to do is get this point to be exactly right here. So I think it'd be, well, I guess I can just roughly get it there instead of trying to do math this late at night. Okay, good. So the game just doesn't even try to do anything. If I go a little farther inwards, then obviously it'd mask that corner, which you can see a little bit right there. And then if I move this to 4, it stops. Move it just barely. Okay, so yeah, it does. I was afraid that it might handle corners differently, but it knows that if it's exactly on the edge, there's nothing to mask. Okay, so it looks like I don't need to do anything else there. So one last thing is we need to cache the arrays. So I'm not sure if it will be that obvious right now. Oh, actually, I should turn off these debugs because debugging logs really slow down the whole game. Let me get rid of that one. Now if we open up the profiler, and then move this down. So all these jumps, I think this has to do with the garbage collection, and it's because we create an array every frame. Where do we actually do that? Yeah, right here. Whenever you pass a list to the shadow mesh, it actually creates an array, and that's not going to be that good for the game. I don't know. It seems weird to me that doesn't like tell you about the garbage collection, but it seems like this frame is just a lot slower, or it's just a lot smaller in time. So I'm just guessing it has to do with garbage. Oh, the garbage collector actually is here in black. Okay, what's the jump and rendering, actually? Okay. It's just the graphics is just waiting, and then if we move back a frame, it doesn't do that. Okay, well, I don't know. Maybe it's just because of VSync and not actually the graphics. I mean the garbage collection, but okay. Well, then maybe we won't worry about it for now. Just turning on. It's kind of hard to see if things are on or not, but I think that means garbage collection's on. And it's not really affecting anything. We can see a little bit right there. Okay then. Well then I guess I won't worry about it right now. I was thinking that the garbage was going to cause a lot of lag, and I mean, it wouldn't be that hard to fix. We just need to make a cache of different arrays and different sizes, but that's not that exciting, so if I don't have to do it right now, I won't. Let's go back to rendering shadows for every light. I guess I'll just leave this here, and this is what we'll work on. Okay, so now it should be rendering a shadow for each light, and this one, okay, there it goes, it was inside the collider. It seems like everything is fine. Oh, I just was moving the sprite and not the actual lantern. Of course, some of these lights aren't actually on or over any collider, but everyone that is not covering up the inside of the collider. And then if we look at our light mask texture, we can see all the different rectangles being drawn. So it's been a couple streams since we dealt with this code, but basically every quadrant is like one lantern's mask, and each mask only looks at one channel, either red, green, blue, or alpha. And so you can kind of see them combine here. Here, one of the lights, I think this is alpha light. Oh, not this one actually. But I was gonna say there's a big cutout here for one of the alpha lights. Maybe it's this one. Oh yeah. So when I move it around, you can see the mask changing. And same with all the other different colors. So what we're gonna do, just a second, I need to clear my throat. Alright, so our plan now, see at the moment we render each of these textures one at a time and then combine all 16 into this one texture, which that works fine, but the problem is that 16 is actually the maximum number of textures that you can handle in a shader. So if we ever wanted to make more lights, we'd just be unable with this system unless we scaled up and did another, like basically fed this texture into another texture, which is I guess would work, but a better way to do it, and also not need to render each texture separately, is just to have the shadow mesh creator create like all the red channel lights at once, and then render that to one texture, and then do the same with each color, and then we'll just combine those. That way we'd only need to send 4 textures into the combination shader, and we could easily add more rows and columns to this just by increasing the render size. So that's what I'm going to try and do now. So I'll have to change this code a bit. Trying to think of the best way to do it and not have to rewrite the whole object at once. So I have this 4 texture to 1. Okay, yeah, and it does. This is actually what we'll need to do. Actually use the UV? Oh yeah, I do. Oh, that was one thing I wanted to check. Let's do this real quick before I move on. Right now we set the UV basically to an empty array, but I'm not sure if I need to do that because our shadow shader actually doesn't need the UV. It just always prints out white. So I'm hoping that the game will work fine if I just don't even give the mesh any UVs. Okay, and it looks like it does. That's good to see. So that actually helps a lot with the garbage collection problem that turned out to not be that big of a deal, but okay, so if we look here, what is this? Is that garbage collection at the bottom? No. It's others, isn't it? I don't know what that means. It says, I guess that's just, no, it's not overhead. But we can see this green part is basically our script. Like this light manager update takes like almost 2/3 of the frame time, and most of it is our camera having to render 16 textures every frame. So yeah, not ideal. And we can bring this down to just rendering 4 textures in this new system, and hopefully it will be much faster. But I want to know, I'm not sure what this brown at the bottom is. It's part of the camera rendering. Some of it's in culling, I don't know. There's no easy way to tell. But so we want to bring down this green part as much as possible, specifically the light manager update function. Okay, so let's go back to that. We can use this 4 texture to 1 shader. Okay, so I guess I'll, just to do a sanity check, I'll change this to just using the 4 texture to 1, and we'll set everything up as if we're only going to use 4 textures now instead of 16. Okay, and you don't need to set the red texture, because the red textures will just be what will pass into the graphics blit down here, and that will be set to this main text variable. Okay, so yeah, this could just be green text, don't need to set a number. And this goes down to 4. Okay, so I'll leave it small for now. We'll just render 4 lights. I guess the mask is 128. And yeah, for 4 lights, we should figure out how we cannot need to hard code in these numbers. Okay, so everything should be fine. These other lights actually will be unused right now. Okay, so what's going on now is the actual light mask is just reading the wrong points. So I wouldn't worry so much about what's happening to the light. Just pay attention to the actual mask texture that we're outputting, and it seems to look fine. And if I move the alpha over, this stuff should get cut out. Cool thing about moving the alpha, since it's the last rendered, you can actually see the mesh in the editor, which does help visualizing it a little bit. It's weird right there how the triangles kind of overlap each other and then move around. Alright, so So now what I need to do, we need to create for light, and then I also should send... So actually we need to have like multiple shadow creators, because they'll each have they'll each control their own mesh. Okay, so let's do shadow creators equals, well, we'll need, okay, so we have 4 textures, but for the shadow creators you actually need 1 for each quadrant on the texture, so we'll have 4 for now. Let's actually, so private, this shouldn't be changeable, this should be like, this will actually be something that's built into the game, so I could use a constant, but this will be fine. Quadrants. That doesn't really make much sense because quadrants implies 4. Okay, so let's do it this way. Num rows. Should I just assume it's square? I guess not. Well, if I'm gonna do this, this should actually be probably in the lights data class, because this is accessible to more objects. So let's see, mask rows and mask columns. So I guess the total number of lights you could have is the rows times columns. Oh no, it'd be rows times columns times 4, because 1 for each channel. So equals new data num mask columns times num mask rows. Oops. Just in backspace instead of closed brackets. Okay, we will need this, so we'll copy it. ILS and shadow creators links. Okay, so another thing we should pass here is we need to give it the offset for the mesh position. And basically it will just be the position of this game object. I'm pretty sure, well, we'll need to subtract it also when we get the light position, but that won't be that big of a deal. It shouldn't change any of the other math, thankfully, but I guess we will need to keep track of it. Let's put it up. I don't need this raycast actually. This is the mesh data. Let's call it world offset actually. Well, the world offset's actually the negative, isn't it? Game object transform position equals mesh position, and then I think here I can just add the world offset right here. Oh, I've got to tell it I want it to add vector 2s. It's no big deal. So let me see if I got this math right. If the mesh is at position 1, 0, so it'd be to the right, and the light is at 2, 0, then this total offset should be -2 to move that to move the light position to 0. So yeah, the world offset's negative mesh position, and then okay. So yeah, so I actually need to keep this positive because we subtract down here. I guess I could add. I don't know if it makes that much difference. No, I'm lost. Where was? I want to get here and just save that normally. That'll be fine. Okay, so now I need to give it the offset. I'll also need to reposition the camera to... Okay, well actually no, the camera can just stay at 0, 0, that's fine. So the offset should be... yeah, let's actually get rid of this. Oh, so okay, let's keep this. This will be boundary size, and let's have I guess light width. Well, no, it needs to be a square, so yeah, light size. So that way I can get rid of some of those hard-coded values. This is actually the radius, isn't it? Boundary radius. Okay, so let's see here. Since we have just... Well, I guess we'll want to change this to be... we want to change the rows and columns to be 2. So the row is I modulo num rows, or it's num columns actually. And then I divided by num columns. Okay, and then of course we need to add boundary radius to that. And then we need to offset so that this is centered. Okay, so it's something like this. Mask rows divided by 2. And oh, this is, keep doing this backwards. Columns is the width. Rows is the height. So if there's 2, this is just -1. But then if it's center, we need to add 1/2, don't we? Let's see if there's 1. Yeah, we need to add 1/2. So let's take a look. If the number of columns and rows is 1, then I modulo 1 is 0. So -1 divided by 2 plus 1/2, so that's 0 for that, which is what we want. And then if this is 2, our number of columns is 2, then 0 divided, or modulo 2 is 0 minus 1, so it's negative 1. Yeah, so we get negative 1/2, so that's what we want. So it'll be centered right here, and then at I equals 1, it's 1 minus 1, which is 0 plus 1/2, so yeah, that should be fine. Yeah, so I think this code is good. So where's the other errors in here? Oh yeah, so now we need to loop through each shadow creator. Let's do creator I equals 0. We actually don't have to. We render. Oh no, we do render once for each channel. So yeah, this 4 should actually go on the outside. So for int channel I equals 0 less than 4. Okay, so yeah, it finds segments for each quadrant. Oh, actually, it just needs to find segments once. So yeah, this can go outside. And then we do it, yeah, we create for light. Okay, and the light would be the creator I times 4 plus the channel, because we because all the reds are at position 0, 4, 8, etc. So creator I plus, or creator I times 4 plus channel I. And then after that, we render once. Yeah, this should actually, I guess that's fine, it's always 4, but it should be 1 texture for each channel. And then we render, and then we call graphic split, which just basically runs our 4 texture to 1 shader and deposits the 4 different light textures into this 1 mask texture. And I think that should be it. No, so now I need to figure out or set all these values. Okay, so the mask texture we actually need to multiply by the number of columns and number of rows. Well, each light texture is also the same. These should be changed to just a single channel textures. Because they're not just for 1 light anymore. And the camera, I think I actually just set the camera dimensions in the inspector. Oh, I set the size in the inspector. And this, but the aspect ratio I don't, so camera orthographic size, and so it's the boundary radius times the number. Okay, the size is basically half of the height, so it's boundary radius times the number of rows. And then the aspect is actually, is it width divided by height? I think so. So yeah, data num mask rows divided by data num mask columns. Which is 1 for us. Okay, so I think that's all set up. So I just need to fill in these. So we'll have 2 rows and 2 columns. Boundary will be 2, and the light size is 128. And let's try it out. Okay, so something is not perfect. Let's just try 1 light. Oh wait, I thought I turned this off. Oh, I just turned off the sprite renderer. Okay. So if we move the visualize cutout somewhere you can see better. It seems like everything is still collapsing in on this position in the center. But it's not even directly centered. Is it? Oh yeah, because I needed to multiply by the boundary size. Okay, so let's try now. Still not perfect. That doesn't seem to have done the trick. Is it, okay, so the boundary size is actually the radius, so it should be boundary size times 2. Let's try that. Okay, so that's looking a bit more right, but the sprites are still being a bit weird, but okay, so now it looks like everything is just offset wrong, but you can see there's an invisible collider there. So that just tells me that the shadow mesh generation code is just being offset wrong. So should it be subtracting? Probably guys got one of the signs wrong somewhere when I was talking about it earlier. Let's just subtract this. Okay, that's still not it exactly. Okay, the texture seems to be right, but now I just flipped it around to the other side. Let's see if I move the platform. And then down here where I call it segment in bounds, it does subtract the light offset, which is what we passed here. So this is in world. Position. So again, let's just illustrate this. So over here, the light is, X should be 0, but then this should be like 1. Let's do it this way. So we want this, or these values to become 0. So if this is at 4 and this is at, or -4 and this is at -5, then what we really need to get is the light offset should become 6 because it needs to scoot this. Because first it needs to like kind of move both of these to 0, 0, and then scoot the well, no, because the light is what needs to become 0, 0. So that was easy because it was just subtracting the light's position, but then we have to. Oh, you know what? Now that I think about it, we don't actually have to calculate the or put in the mesh's position into this calculation at all. Yeah, so I was just overthinking it because the mesh's final position doesn't actually affect any of this math, because the math only cares about the light's position and moving that to 0, and then everything else just works. So yeah, that was kind of a brain fart on my part, but yeah, it looks like everything is good now, and our new system seems to work fine. So another thing we have is, you can see, we can't really see here, but in the game you can see there's this one row of pixels, and that is just because up at the top some of the shader lookup, or texture lookup in the shader, rolls over to this white part. And one way we can fix that is by adding space in here, or basically extending the boundary out a little more past the size of the light, so that there's just a little bit of edge space. The only problem with that is that we'll have to mess around with the size of the light, with the texture again. But I guess it is pretty important to do so. Let's try to see if we can figure it out. Okay, so yeah, I don't need to do that. And yeah, we don't need to do that anymore. So yeah, I think we're almost done with this project. Just look into what do I call? Yeah, the artifacts, edge artifacts. So one way I think to do it is to actually just increase the boundary size a little bit. But I'm trying to think about how that would work just in terms of math. I mean, obviously, I think if I just went ahead and changed it to like 2.1 here, nothing would actually change because the texture size is the same. And I think actually everything will still work exactly how it did before. Yeah, it's because the boundary size is only the size of the mesh is created, and then the camera, so it still renders the same texture. So I'm trying to figure out how I want to do this. Serialize field. Spacing. I guess really the spacing areas could just always be black, so maybe we don't need to render the mesh out any further. I don't know, that might add some other weird problems. Okay, so I think actually, yeah, we need to... might not need to change any code here. I think what we might have to do is just restrict the UVs in the actual lantern creator, or where is it? The light mesh creator. Because right now we just go to the total edge of the quadrant. Where's the shader for this actually? Maybe I could just do it in the shader. Select quadrant mask. So right now the UV2 is telling the game like what quadrant this mask is in. So it's either 0 or 1/2. But what if I just added like a tiny bit to it and then restricted this so that it never gets exactly to 1? That might work, and I won't have to change how any of the camera renders. Not sure the syntax. Okay, so float 2x plus something very small. I guess let's be divided by 2. So I guess we'll want to divide it by just something slightly bigger than 2. Yeah, this is, I don't know exactly how well this will work, so I'm just going to test it out. Oops, that's way bigger than 2. Okay, so let's try this one. Correct number of arguments. To numeric type constructor at line 58. Oh, there's no lines in this. Okay, there should not be lines in shader code. So, oh, okay, yeah, this should be y, and x. Let's just see if this hopefully doesn't make everything explode. Okay, so it looks fine. Oh, we still get the artifact, so it doesn't actually fix the problem. I wanna... Let's just increase this a little more and see if this, in theory, does fix the problem, because I want to finish up this project tonight, and so I don't want to like go and ruin all the code. Okay, this kind of fixes it. Actually, no, it makes it worse, doesn't it? Okay, so yeah, this, let's not do this. So yeah, I think I will, if we wanted to fix this problem, we need to add spaces into the what am I trying to say? Spaces into texture, which I guess we can still do pretty easily, but we'd also need to change this code because the UV2 wouldn't be exactly from 0 to 0.5 anymore. So I guess well, I.UV actually needs to be divided a bit more, doesn't it? Because like this also assumes that there's only 4 rows and 2 columns. So kind of what happened is we would like lerp between the UVs. I'm trying to think the right way to say this. Lerp between the two corner UVs here given by this value. I'm not sure how to do that in the shader code. Because see, if this range was from 0 to 5, well, I guess it wouldn't really. I think all I have to do, yeah, I think I'm overthinking this. So basically the mask is just, we just use this UV2, and we wouldn't even use this I UV at all. And then for the light we just use the normal UVs, and then we just put the actual mask UVs here in the light mesh creator. So for now, so the first one is 0, 0, and then vector 2, or let's do it this way, quadrant plus new vector 2.5 to 0, and that's bottom left, oh wait, bottom right. And again, this is still hard coding in a 4 light or 4 mask texture. But I think this will be much easier to extend to variable numbers. So this basically just gives us the UVs on the mask to apply to the sprite. And I think this should work. Okay, yes, looks good. Let's try some other quadrants just to check. And here. And here. Okay, so now we're ready to accept spaces in the texture. Alright, so how do I want to handle this part? We don't need this offset to be stored here anymore. So basically, when we create the texture, we'll need to add in some values for the spacing, or some pixels for spacing, which I guess could be as little as 1 more pixel. And then we need to space the meshes apart a little more, although they would still need to render to the edge. And in order to not get more artifacts, we'd have to make sure that we extend the boundary by just enough for that border. Okay, so I guess we just leave the boundary radius as it is. But we'll have to, like, because right now the boundary radius adds up exactly to the size of the light, because the radius is 2, so the light's diameter is 4, which equals 128 pixels, since 1 unit is 32 pixels right now in our game. So let's see, private int bleed border. And I guess, okay, so we'll just leave this boundary radius here. Okay, and yeah, so that'll be all the same. The bleed border is actually going to need to be inside the data because when we create the mesh UVs, we'll need to know that. So let's see. This should be public, is what I was trying to do. Okay, so the boundary stays the same. We'll just have to adjust this manually ourselves. The light size is the same, except we'll just need to add on the border. Yeah, this code is starting to get a bit huge, so we'll add some spaces in there to clean it up. Okay, so I'm gonna be a little lazy here and just add the bleed to both sides of the light. Even though obviously the total mask, even though obviously sides that are on the edge of the texture don't need to have a bleed border. So technically we could save a little space by doing that. And there's also, you need to worry about textures work much better as a power of 2 with sizes excuse me, when their size is a power of 2, but that's just something that we can fix up later. It won't really be that difficult. We just have to render a texture that's bigger to fit all the lights but still be a size of 2 or power of 2, and then we just adjust the UVs. So that's okay. Is that all I have to do here, I think? Okay, well, these actually will have the same size here. In fact, I should just use the mask texture length and width. Oops, this is dimensions. Okay, that's not what I wanted. I want to get the length of this. Okay, there it goes. I guess I was thinking I had to be crazy. I knew that there was a way to get the dimensions of the texture. Okay, so yeah, the aspect, that's still fine. But the orthographic size, oh no, this is still fine because it's based on the world, not the texture. Yeah, so this is all good. I think the code, it'll still run now, but the mask will be a little messed up. Well, actually, it will be the same now because the border is 0. So if we want to have 1 pixel on each side, let's actually make it bigger so we can see. And so the boundary radius, we need to add 8 pixels, which is 8 divided by 32, that's 1/4, I think. Oh, except, yeah, that's fine, because the border is radius. So yeah, things will be a bit weird right now because Basically the mask is kind of like 8 pixels around. So that's why we need to adjust the mask's UV. What am I trying to do? So get the light mesh creator. Okay, so let's see. So the quadrant. I guess this should probably actually be past that information. So yeah, we should just go ahead and pass it the like the bottom left and the top right. Okay, so bottom left UV is just this. Yeah, because this code doesn't deal with more than 4 quadrants, so we can fix that. I mean, it won't be that difficult. And now we need to add a bit onto it for the border. So we need to know how much. So again, UVs are normalized space, so that 0, 0 is the bottom left and 1, 1 is the top right. So the border is 8 pixels, so we need to know like what percentage of the texture 8 is, and we'd add that. Too many L's. Actually, let's calculate that up here. So border, UV size. I guess we can just hard code it for now. Do we have? Yeah, we do have the mask texture. And this has the light data. Does it not? I guess I need to get that. I guess it doesn't need it outside the setup. Okay, so light data equals find object of type. Again, this can be a lot more efficient, but probably if we pass the data in here, but this will be okay. So data, and it's actually, since the mask does not have to be a square, we need to do this separately for the length and width. Okay, so border UV size is new vector 2. So data, bleed border times data, actually it should be the other way around, mask texture width divided by the bleed border, and contrast to a float so that we'll get float division. Okay, so now the bottom left is just this plus the UV size, and then the top right, we can just add 0.5 to each of these and then subtract the border. I guess we'd have to subtract border times 2. Yeah, because this is the original width, but then the new width is minus both the bottom left and top right borders. So that's good. could, I think, although this is dimensions, so this should be plus that. Okay, and then here, so this is bottom left, and then we got top right. And this will be a little different. Basically, wherever it says 0.5 here is we take the top right's value. So new vector 2, top right x, and then the bottom left y. And then we want to get this top right, and then new vector 2, bottom left x, and top right y. Oops, no semicolon. Okay, so hopefully this will work, because I'm just about out of time. Okay. So the texture is still working good, but something is wrong with the UVs, obviously. Where is that code? Here. Why don't I store this, the UV data, just so I can kind of see what's getting printed out? I don't really have to do anything fancy. So yeah, I just want to have those available so I can actually look at them. Okay, that's not right at all. They need to be between 0 and 1. Oh, I bet... Yeah, here I did it backwards. It's the border divided by the width. Same with here, the border divided by the height. Before I was counting how many borders can fit in the texture, which yeah, is going to be a lot. So again, let's cut this out. Oh yeah, that looks good, and look, no artifacts. And if I move this around, the shadow is still hugging. There's a little bit of like movement in the shadow, and I think that has to do just with pixels popping in and out. Probably could fix that by having a more pixel perfect shader, but we've mostly got the effect we wanted. Let's try another light. And then alpha 3, which is the very last one, and it works. Probably the pixels popping in and out. I don't even know if you can see it on the video, but like when I move this back and forth, I can see this line here changing, and I think it's mostly because of floating point rounding. So I bet you could fix that by having a bigger light texture there, or mask texture. But since I have so many values hard-coded in, I don't know if I could easily test that out, so I don't worry about it at this point. Cool. So now we've pretty much solved all the problems, and if we could easily extend this to have more lights, oh, we should look at the performance. Okay, so let's turn these all back on. Oops. What's this one? Okay, that was this. think it makes much difference if they're on or off the screen, but okay, so window profiler. Okay, well, like, green is still pretty big, but it looks smaller than before. Oh, it's I don't know what that spec was. Oh, when you turn back on VSync, you can see it's much better. Actually, look, the script only takes up about 20%, or 17% now of the whole frame, when before it took up, like I said, almost 66%. And again, the rendering is by far the biggest thing, but we only have to do 4 renders every frame. I'm pretty sure... Well, I guess you could maybe cut it down to 1 render if you just did every light onto 1 texture, but then you are going to quickly run into the maximum number of lights allowed. And yeah, this blit basically takes up no time, so it's good to see. And still, yeah, it's just drawing. I don't know. I'm surprised that this render takes up so much time because the there's barely any triangles, but I guess that's just the nature of the beast. But yeah, since we render 5 times every frame, I'm pretty happy with it. Let's look at the frame debugger. We can actually see the draw calls. That's a little bit hard to read. Oh yeah, here we can see the mask textures. So this must be where we called the blit. Okay, this is like the actual scene, I think. Yeah, opaque and transparent. And then we have an image effect at the end. I didn't know we had anti-aliasing, but interesting. Anyway, yeah, I think that's gonna be it for this project. So I hope everybody that's watched has enjoyed it. I've definitely learned a lot, and I think this effect, well, basically just being able to render something to a texture and then use that texture for some kind of data is really useful. I've seen other people using it for as interesting things as like wind patterns in a sailing game. They actually had the camera render like effect fields of wind, and like, I don't know, magenta would point north, for example, and then they used that to find the pattern of wind on every position on the map. That's another way you could use code like this. So yeah, it's very useful, and I've definitely enjoyed playing around more with shaders, so I think I have some other problems I want to try to solve, so we might come back to it, but definitely soon we'll continue back on the Tactical Lizard Tamer game, and well, actually might do some shaders soon on that because I want to do like create a nice looking map, so that will be fun. But yeah, thanks again everybody for coming by and watching, and I hope again that you enjoyed this project. Yeah, I'll probably put this up on GitHub, so look forward to that. And if you missed any of my streams and you want to catch up, you can check out my YouTube channel by looking in my channel description or typing !YouTube in chat. And if you'd like to talk to me and other viewers, I do have a Discord channel, so feel free to join it. You can find that in the channel and video description, as well as by typing !Discord in chat. And I should be back tomorrow working on our large Pokemon Fire Emblem-like game, codenamed Tactical Lizard Tamer. It has modding support and online multiplayer, so it's a pretty big project. I've been working on it for a couple months, taking a small break, but we'll be back to it tomorrow. Should be there about 8:30 Eastern, and hopefully my throat will be a little better. But I guess it's held up pretty well tonight. yeah, I guess that's it. Again, thanks everybody. I hope you have a great night. Bye bye.